Hello, welcome to our very first geometry video, the basics of geometry, points, lines, and planes, section 101. Our objective for this lesson is to be able to name points, lines, planes, segments, and rays, sketch the intersection of lines and planes, and then solve real-life problems involving lines and planes. So first to talk about the three most basic geometry concepts, the point, the line, and the plane. These are what we call the undefined terms, meaning they have no set definition. It's just understood what they are. Okay, so first off, let's talk about a point. A point has no dimension, meaning it has no measurable sides. It can't be measured. Where then it means no dimension, it can't be measured. It has no length, it has no width, it has no height. Okay, we represent this idea. It's really just a location in space. So a point is really just a location in space. We represent this location with a dot. So on a piece of paper, if we want to talk about a point, we use a dot, like this dot right there is a point. And to help us refer to dots, to help us refer to them, because here if I had numerous points, let's get some more points here. And if I told you to go circle that point, you wouldn't know which point I was talking about. Now if I said this down here is point Q, if I told you to go circle point Q, you would know exactly what point I was talking about. You come down and circle that point. So we give points a name. They are named with uppercase letters. So they are named uppercase letters. So we name them with uppercase letters. Okay. So we talk about point A. So instead of it having a name like Bill or Ted or Fred or Melanie, okay, we name it point A. So we talk about, hey, there's point A. Point A's over there. Yeah, he's over there next to point Q, blah, blah, whatever. Okay. So that's a point. Now a line. A line has one dimension, length. So a line here has one dimension, length. It is represented by a line with two arrowheads, but it exists without end. Okay. So this line here, this line right here, okay, we show it ending here and here, but we put arrowheads at the end which show that that line goes on for forever. So it technically doesn't end. It goes on for forever in this direction, forever in that direction. But we just put arrows on the end to show it goes on forever without having to draw it for forever. Okay? So through any 2 points, there's exactly one line. Basically what that means is I need to have 2 points to be able to draw a line. Okay, so here if I just put one point out here, and let's call this point M, excuse me, and I asked you to put a line through point M, you wouldn't know which way to put it. Now if I put another point up here and labeled it N, and I said put a line through MN, you'd know exactly what I was talking about. You'd know I was talking about this line right here. Arrow on each end showing it goes on forever. There's point M and N. Let's get rid of you. Okay. Hey, now how we name a line, we name it either 2 different ways. We either name it by 2 points on it. So here I could call this line MN. Okay. We name it with 2 points, uppercase points, so we name it by 2 points that are on it. Or we name it by a lowercase letter. Like you see here, this lowercase L right there. I could also call it line. So here, let's not do MN. Let's talk about line AB. So I could call it line AB, or I could call it line lowercase L. Okay. And in mathematics, we like to be as short and concise as possible, so we can actually shorten it up and use a symbol above the top. So instead of saying it in words like over here, line AB, I can do it in symbols like right here. Line AB, there and highlighted, it has the symbol above it instead. So basically it's the 2 points that are on the line, A and a B, and then a line mark above it with arrows, what are you doing with arrows on either end. Shows line AB. Or you can call it line BA, basically just any 2 points, but we only use 2. You only use 2 points, never any more than 2. There are an infinite number of points on this line. I can talk about all the points here that are on this line like that. So there's a point here, there's a point there, there's a point there. There's points all the way along that, but we really only have 2 that are named. So the 2 that are named are what we use to name that line. Okay. All right, so that's a line. A plane. A plane has 2 dimensions. It has both length and width. We represent it with a shape that looks like a floor or a wall, but it's important to notice here it extends without end. So here, these lines here along the outside are not the end of this plane. It's just how we draw it on paper. It's really hard to draw a plane on paper, okay? So that's just how we draw it. But in fact, it goes on for forever and forever. So if we think about it, if we look at the room we're sitting in and we look at the wall, we imagine if that wall went forever and forever in all directions, that would be a plane, okay? So just like for a line, we need 2 points to have a line. For a plane, we need 3 points. Any 3 points, not on the same line, there's exactly 1 plane. So we can use 3 points that are not all on the same line. Your 3 points cannot be all lined up. Like if you notice this A, B, and C aren't all in one line. If they were all in one line, there's a lot of different planes we could have that would go through that line, and we can talk about that more in class if you don't quite get it. But we use 3 points that are not all on the same line to name a plane. So I would call this here, we call it plane ABC. Or we just use 1 uppercase letter, plane M. If you notice there, M doesn't have a point near it, because it's not a point, it's a plane. It's plane M, it's the name of that plane. Okay, so a point, a line, and a plane. All of our other geometry concepts are made out of these figures, a point, a line, or a plane. Okay. All right, so we want to give 2 other names for this here means line PQ and plane R. So first let's find line PQ. So over here in the picture, let's see, there's P, there's Q, so we're looking at the line that goes through PQ, so we're looking at that line right there, so we could call it line PQ. Well, first off, I notice there's a lowercase n right here. Lowercase, it's not by a point. So that's one name of that line, so I could call it line N. We can't use, we can't use that little shortcut notation with this line right there when we're using a lowercase letter, like this lowercase n. We wouldn't do, this isn't right, we wouldn't do, oh, that does not look like an n. We wouldn't do this, an n, and then do this on top. Okay, that's a big no-no. We don't do that. Okay, we just call it line N. Okay, we want 2 other names. Let's give another name for that line. Let's see, well, we went P to Q. Well, I could go the other way around, Q to P. So I could call it line Q to P. Since I'm using points, I can use the line above it for the symbol. It's line QP. So now we want 2 other names for plane R. Well, plane R is made out of, well, there's my R right there. So there's my plane R right there. So plane R is the plane that has R in it. So it'd be this plane right here. So I could call it plane R, but I could also name it based on 3 non-collinear points. So I could call it plane, let's see, VSP. Those aren't all in one line. Or I could call it plane VTP. Those are all in one line. But I couldn't do plane S. I couldn't go plane SPT because those are all in one line. I can't do that. Okay. All right, so example 1, part B. Name 3 points that are collinear. Collinear, that's a new word. What the heck does that word collinear mean? Collinear just means on the same line. Collinear is on the same line. Okay, so I want to name 3 points that are collinear. So I want 3 points that are on the same line here. Let's get rid of a bunch of my stuff in there. So we want 3 points that are on the same line. Well, let's see. I have 2 different lines here. I've got this line here, but I only see 2 points, a Q and a P. Okay, and then I've got this line right here. That's got 3 points, an S, the P, and the T. I've got the S, the P, and the T. So those 3 points are all on the same line, so those are collinear. Point S, P, and T. So if we're just talking about points, we just use the uppercase letters. Okay, so now we want to name 4 points that are coplanar. Coplanar is a lot like collinear, on the same plane. Coplanar means on the same plane. Okay, so coplanar means on the same plane, so looking for 4 points that are on the same plane. Here I have this plane right here. Let's find 4 points that are on the same plane. Well, I only see 4 points on that plane, V, S, P, T. So coplanar would be points V, S, P, and T. Those are my coplanar points. Ooh, gee, sorry. All right. Next, example 2. Give another name for, wait, do we not talk about segments? No, we didn't. Let's go ahead and let's add that. Did I forget that? Just a second. Okay, this is what I was looking for, our definitions of segment, ray, and opposite rays. So we've talked previously, we talked about our 3 undefined objects, our point, our line, and our plane. So we have our point, our line, and our plane. They don't have formal definitions, it's just an understanding on what they are. Okay, our next bit of vocabulary, these are definitions, and they're actually defined in terms of our points, lines, and planes. Okay. So in these definitions, they use line AB. They write it as the AB with the line symbol above it, and they're talking about points A and B. So all of them refer to this original line. So if we break down this original line and talk about parts of the line, I can talk about just the piece in between A and B, ignoring this part that goes on forever. If I do that, I have what's called a segment. We call it a segment or a line segment. Okay, and we name it, again, by its endpoints. We name it by what points it is at end, A and B. And it's very similar to a line, but instead of like a line going on for forever, a line segment has ends. It ends at certain points. We name it using its endpoints, and then here we have there that notation, that AB with the segment sign above it. The only difference between the line symbol and the segment is a line has arrows on the end. A segment does not. The arrows up here denote that it goes on and on forever. The lack of arrows here means it ends at A and it ends at B. So it has 2 endpoints. Okay. Now, if we're just talking about one of the endpoints and go on for forever, let's say I just wanted to start here at A. I wanted to start at A and go this direction for forever. That would be a ray. So we'd call it ray AB. Okay, written as, then there's the symbol ray AB. If you notice, it has no arrow on one end, but an arrow on the other. It has an arrow over here. That is a little bitty arrow in there. Okay, the arrow in this ray symbol is always on the right side, regardless of which direction it goes. So, and we always list the endpoint first. So this thing, this A right here, would be the endpoint of that ray. So it starts at A, goes in the direction of B. Okay. Okay, and so if you notice then, depending on which endpoint you name first, like here, if I have ray AB, that means I'm going to start here at A and go in the direction of B. That's that ray. Okay, but if we say ray BA, that's actually a completely different ray, because that ray starts at B and goes in the direction of A. So you always list the endpoint first. So this is always the endpoint first, and then the arrow on that ray symbol is always on the right side. So this arrow doesn't really denote which direction it's heading. Really, which point you put first or second kind of gives you the idea on which direction it's heading. Okay. Now opposite rays, down here, opposite rays. Okay. So you need to have, if you have a point C and it lies between 2 points, okay, on a line, like here, we put point C, there's my point C, in between A and B. Then if I do a ray starting at C and going towards A. And then if I do a ray starting at C and going towards B, those are what we call opposite rays because they're on the same line but heading in opposite directions. It's important to note that not opposite rays is if I had, let's say, a ray starting here and going this way. So here, let's say it started at, let's give it a different name instead of A and B. We're doing a lot of A's and B's. Let's say M, and then here's N, point N. And then I have one that goes from M and goes this direction, point P. Those are not opposite rays because they're not all on the same line. It needs to be on the same line for them to be opposite. Okay. All right, now let's use example 2. Let's use these new definitions. We want to give another name for segment GH. So we're talking about segment GH. It's the segment that goes from G to H. It's that segment in there. But since a segment has no direction, I can also name it the other way. So I can call it segment HG with the segment sign above it. HG, so it's part A. Okay. I could call it segment HG. Okay. All right, now part B, it says name all rays with endpoint J. So we want all my rays to start here in the middle at J. So all my rays are going to start there at J. So let's get rid of this segment. Name all rays with endpoint J. Which of these rays are opposite rays? Okay, so I could start here at J, and I could go to G. So I could do ray JG. So I could go ray JG. I could go J and go to F. So I could have ray JF. I could start at J and go towards H. So I could have ray JH. And then I could start at J and go to E. So I could have ray JE. So now it asks which of these rays are opposite rays. So we want them on the same line. So if I'm looking at this line here, well, that would be ray JF and ray JE. So JF and JE, these two are opposite rays. Okay, so those are opposite. And then JG and JH are opposite. So then these two guys are opposite. Those are opposite rays as well. All right, so now an intersection. And we kind of know if I have the intersection of two highways. So let's say here is, let's say this is just the highway, Highway 12. And then here is Main Street, it goes like this. There's Main Street. The intersection would be this spot right here. Because this spot of the road is both on the highway, it's both on the highway, and it's also on Main Street. So this spot right here is on both of them. So an intersection is a point or points, there could be more than one, that lie on two or more figures. So basically it's any point or points that are on two different figures. Okay. So here if we want to sketch a plane and a line that is in the plane. Okay, so now how to sketch these things. Well, if we go back to our notes, we see here, we talked about a plane, they sketched it using this, it's actually parallelogram type shape. So we're going to go ahead and we'll sketch a parallelogram type shape. So let's go ahead and we'll sketch ourselves a parallelogram. And let's give it a name, M. And we want a line that is in the plane. So I want to show a line inside of that plane. So I'm going to go ahead and I'm going to draw a line inside of that plane, and we'll call it lowercase l. So there is a plane and a line in that plane. So we're thinking about that intersection idea, points that lie on two or more figures. Well, if we notice, all the points on this line L lie in this plane M. So their intersection would be all the points on line L, because all the points in line L are also on the plane. Okay. So now for part B, we want to sketch a plane and a line that does not intersect the plane. Okay. So again, let's go ahead and let's sketch our plane again, that trapezoidal figure. Okay. There's my plane. We'll call this plane N. And I want a line that's not in that plane. So I'm going to make it obviously I'm going to make it like way down here below. Obviously not in that plane. we'll call it, I don't know, lowercase w. Okay, so there's my plane and the line that does not intersect the plane. So that line, there are no points in this plane, because again, this plane goes out for forever. It doesn't actually end right there at those edges, but this plane and this line never ever intersect. So now this last one, we want to sketch a plane and a line that intersects the plane at a point. So let's go ahead and let's sketch up our plane again. And again, we want to label it, let's uppercase P. And we want a line that just intersects the plane at a point. So I'm going to make it look like I have a line coming straight down and just passing through the plane just at one point. Basically, imagine like I come down and I take a spear and I jab it through the plane. So it's just going through it at that one point. So to make it look that way, okay, I'm going to draw a line coming straight down, and let's say it meets the plane right there. At this point right here is where it hits the plane. And then now it's going to be back behind the plane because this plane kind of is coming out at me. So I'm going to do a dotted line the rest of the way. So it shows that, hey, this piece here is in front, this piece here is behind. So because this plane is actually blocking this back side of that line. And so then it intersects at just this one point right here. I don't know if we can call it X. And we'll put another point on here, Y. So that line is line XY. It intersects at point X. Okay. All right. So now you have some your turn problems to do. So I want you to go ahead and do those your turn problems. Do the best you can. Attempt them all. They're really just discussion type questions. We'll discuss them in class and then in partners, teams, whoever else is done, and then you can get started on your practice.